All right, so now we've talked about receptors, and we're going to be moving up into the thalamus and the primary and secondary cortices. So when we have information that comes in, we have our touch here and on our finger, and it activates those receptors and it sends the signal here. You have the first connection in your dorsal root that travels then to your spinal cord, and the ventrospinal thalamic tract receives input from pain and temperature. Travels right here. And the dorsal column, this relays fine touch and pressure sensations. So you have temperature on one side, and then you have touch and pressure on the other side. They travel up and they carry this information to the thalamus in here. And once it's in the thalamus, then the sensory information can branch out to the primary somatosensory cortex. And the primary somatosensory cortex, which is right up here, receives all of the somatosensory information. So it receives information for touch, for pain, for temperature, for proprioception. It receives everything. Just as you have a primary motor cortex and a secondary motor cortex, you also have a primary somatosensory cortex and a secondary somatosensory cortex. So your primary somatosensory cortex, this receives projections from the thalamus. So this is information that's coming fresh up from the body, and it begins the process of constructing perceptions from that somatosensory information. Next, it gets sent to the secondary somatosensory cortex. This is located behind the somatosensory cortex. It's roughly in this area right here. So 3, 1, and 2 is your primary sensory cortex, and then here you have your secondary sensory cortex. This refines the construction of perceptions and projects, and it sends this information to the frontal cortex. Now, within the somatosensory cortex, we have information is organized in accordance with the types of receptors. And so originally it was thought that there was one single homunculus, just as in the motor cortex, that you have a bunch of receptors in your lips and your fingertips and your thumb and your palm, and so you're going to have greater representation of these within the somatosensory cortex. But more recent work actually suggests that there are 4 separate somatosensory topographical maps, or homunculi, and that they actually correspond with some of the different types of receptors that there are. So we have one area that processes somatosensory information from muscles. We have 2 areas that process somatosensory information from skin, one of them being slow adapting and one of them being fast adapting. And then we also have area within the somatosensory cortex that process sensory information from joints as well as pressure. And this is roughly what it looks like. So here's our somatosensory cortex. The motor cortex would be right here, and again, it's going to have a relatively similar mapping. So instead of there just being 1, there's actually 4. And it follows a similar organization as that one, that they all have this basic, you have your tongue, your face, it's actually your hands, and this is the trunk of your body, and there's your foot. So you have all of this mapped out similarly for the different types of sensory information. Muscles, the slow skin responses, the fast responses to the skin, and the joint pressure information. So now that you know a little bit more about how the somatosensory cortex is organized, I'm going to chat with you a little bit about the role of the somatosensory cortex in confirming movements that have taken place. So when you have damage to the somatosensory cortex, it does not actually disrupt plans for making movements, because that would occur in the frontal lobes. But it does disrupt how the movements are performed, and it tends to leave their execution fragmented and confused, because while the movements are planned in the frontal lobes and they're executed in the primary motor cortex, when you execute a movement, you need feedback, somatosensory feedback from the body as to how to best perform that movement. And so if you don't have somatosensory feedback from the body, then when those movements are executed, then it tends to be jolting and discoordinated and sometimes fragmented and confused. Because if you recall, there's a feedback loop between the amount of movement how your body makes moves, if you recall, there's a feedback loop between how your body moves and then confirming that those movements have taken place via somatosensory information from the body. So if you don't have that somatosensory information from the body that basically says, okay, look, I want to reach out and grab this cup that's in front of me. I've reached out and grabbed the cup. Now I can feel myself grasping the cup. I can feel the weight of the cup in my hands. So if none of that stuff can be confirmed, then your body does not know as well how to execute the various types of movement, how much force should be used, and then you're not going to engage in the type of coordinated movement that we all take for granted. When you can't complete a plan of action accurately, this is known as apraxia. And apraxia also would involve an impairment of voluntary movement. So individuals with apraxia can sometimes engage in automatic movement, but they have much, much greater trouble engaging in voluntary movement. So if you were to tell them to stack some blocks, to pick up a cup, they would have trouble coordinating the movement and some of the sequences of movement and coordinating the movement and the received somatosensory information with how to pick up or act, how to pick up an object or how to act appropriately. So within the somatosensory cortex, we have two streams of information. We have a dorsal visual stream that projects to the somatosensory cortex and then to the frontal lobe. So this is what we talked about in chapter 9. When you have the two streams of visual information, they're both going to come back a little bit here. So to return to chapter 9, when you are processing visual information, once the information leaves the primary visual cortex, it travels to the secondary visual cortices, and then it travels along two parallel paths, one being the dorsal pathway that goes into the parietal lobe, and the other being the ventral pathway that goes ventrally into the temporal lobe. So continuing sort of this dorsal stream that projects into the parietal lobe, that dorsal visual stream that projects to the parietal lobe, that projects to the secondary somatosensory cortex. So this provides visual information that is integrated with the somatosensory information to produce unconscious movements. And so when you move and when you're receiving information from the environment, it's really helpful to have visual information accompany that. And it will be a particular type of visual information about what is occurring in space. And sometimes when you process this visual information, it will involve how you interact with it. That's the dorsal pathway processes where an object is in space, whereas the ventral visual pathway processes what an object is. So if this dorsal pathway processes where an object is in space, then it travels into the somatosensory cortex. Then it's going to be, at that point, gathering somatosensory information about where this is in space, where it is in your own space. Is this object touching you? Is it nearby you? Is it far away from you? If it's nearby, how is it touching you? How is it affecting you? So all of that information is being processed and combined there. The secondary somatosensory cortex also interacts with the ventral stream by providing conscious haptic information about the identity of objects and completed movements. And you'll see this more in the next slide. So here are the two visual streams. As I remember, information comes in here in V1 and it travels out to the extrastriate or the secondary visual cortices, and then you have parallel processing where the information is sent up to the dorsal stream here and to the ventral stream here. The dorsal stream, this extends into the secondary somatosensory cortex, and this will often have the information that takes the visual information along with the somatosensory information for how you would interact with your environment. And this information continues to travel forward into the frontal lobes. So here we have this dorsal visual stream that meets up with the secondary somatosensory cortex. So it brings in all of this somatosensory information, touch, pressure, pain, stuff like that, that then gets combined with some of this visual information and continues to travel and send these representations forward to the frontal lobe. So this is one path. Then you have another path here that also leaves the somatosensory cortex, and this travels down into this ventral temporal lobe area. And this meets up with the ventral stream. So you have information that is processed, again, from the visual information travels ventrally. This is the what. This is the what pathway. This is what information is, what is its name, what do you call it. This is central for identifying information. When you have this, the somatosensory information that's coming down ventrally into this ventral path, it's providing information about the object's size, shape, and texture that can be used for identifying the object. So one of the things I'll chat briefly about here is when I was in the visual chapter, I believe I mentioned a condition called agnosia, which is when you have trouble naming objects. So if you were to have damage to your ventral stream, that you would have brain damage here, you would have problems naming objects by name. And so individuals that have this agnosia, what is interesting is if you put something visually in front of them and they can't interact with it, then they have lots of trouble naming it. They'd say, I just don't know what it is. You could put a pair of sunglasses in front of them, and if they couldn't touch it, they would be like, oh, and they would be able to name some features, but they would actually have trouble identifying it. So they might say something like, oh, I don't know. It's, oh, this is a hard one. It's something, it's the sun, and there's a shade, and head, and they would have some of the associations and features that are attached to the representation of the sunglasses, but they would actually not be able to say what they are. Now, if you have those people with the visual agnosia, if you let them touch the sunglasses and you say, well, here, now can you tell me what they are? And you put the sunglasses in their hand, then they will touch them and they will measure the size, shape, and the texture, and their hands may automatically start to know what to do with them. They'll put them on their head or put them on their eyes, and they're like, oh, these are sunglasses. So you see here, this is where you're going to have object identification, and you have two routes to getting to object identification. You have your ventral stream that comes in for visual information, and you have the sort of somatosensory stream that comes in here. So then you can identify objects by basically how they look or how they feel.